I'm Alvia Gaskell, the President of Environmental Reference Materials. I want to talk to you in this video about global climate change and how its impact can be lessened using modifications of existing technologies. Global climate change due to global warming caused by increased infrared radiation in the lower atmosphere due to man-made greenhouse gas emissions, mostly carbon dioxide and methane, is probably the most important environmental problem of the 21st century. And it may reduce crop growing yields in regions where crops will grow, it may reduce surface water supplies due to changes in precipitation patterns, and it may lead to flooding of coastal areas, among other unacceptable outcomes that are predicted by the end of this century. The emission of greenhouse gases is closely tied to power generation, energy recovery, transportation, and food production, large sectors of the world economy that serve as the basis for modern civilization. It is unlikely that significant reductions in emissions in these sectors will be achieved by technological changes for decades, perhaps for as long as 50 to 100 years. For example, even if hydrogen fuel cells were to replace internal combustion engines in motor vehicles today in 2003, it would take 20 years to replace the existing fleet of vehicles. Likewise, the lifetime of power stations is around 35 years, so any changes made today would not be effective worldwide until almost 2040. The reality is that no sea changes in transportation and power generation are on the horizon. Fuel cells are too expensive and have other problems that currently limit their applicability in transportation to prototype vehicles. Carbon dioxide capture and disposal technologies developed by the oil and gas industry are too expensive and have never been applied on the scale needed to be effective for existing power stations. New power stations based on designs that control greenhouse gas emissions will not see widespread use for many decades. And little progress has been made in significantly reducing other sources of greenhouse gases. Given the problems with emissions reduction technologies, what can be done within a decade to buy time until these technologies are perfected and installed worldwide? Because we know eventually they will have to be. Well, instead of reducing emissions, another way to limit the impact of global warming is to reduce the amount of infrared radiation produced by the surface of the Earth as a result of the contact of the surface by shortwave radiation from sunlight. It is this upwelling infrared radiation that interacts with the greenhouse gases and produces the downwelling infrared emissions that cause the greenhouse effect, keeping more heat energy in the lower atmosphere than would be there otherwise. Several unrealistic proposals have been made before to reduce incoming solar radiation from outside the atmosphere with mirrors and from within the atmosphere with reflective balloons or sulfate aerosol particles. For technological and environmental reasons, none of these proposals can or ever will be implemented. It should be possible, however, to achieve a significant reduction in the upwelling and downwelling infrared fluxes by covering certain desert lands with highly reflective white plastic. This surface cover will increase the albedo, or surface reflectivity, over the entire spectrum of incoming radiant energy from the sun, from about 0.35 to 0.8, with 1.0 being 100% reflective. Thus, some of the energy that powers the greenhouse effect will have been sent back into space, and the warming that would have occurred will have been offset in proportion to the amount of land covered. Around 4 million square miles of coverage will offset all of the expected increase in infrared radiation from the years 2010 to 2070, as well as all of the expected additional warming of the Earth over that time period. This would give engineers and industries approximately 2 to 3 complete cycles to overturn the existing capital stock and in vehicles and power generating stations, and more importantly, that much more time to create and deploy a new energy infrastructure based on hydrogen fuel cells and power systems that do not emit greenhouse gases. Although it may not be possible to cover 4 million square miles with plastic, 1/5 of that amount of coverage, 800,000 square miles, would offset all of the warming due to either transportation or electric power generation over the 2010 to 2070 time period for the entire world. And much smaller areas could offset all the warming due to, for example, U.S. power plant emissions or the emissions from a single U.S. company or industry. One of the major problems with such an approach is how to keep the surface of the plastic reflective in spite of the impact of dust and soil from sandstorms, dust devils, and the normal dry deposition of atmospheric particulates. In this video, the concept of using unattended robotic vacuum cleaners to perform the task of keeping the plastic clean is demonstrated. The plastic used is a white 4 mil, 4/1000th of an inch thick polyethylene construction film. When new, it has a glossy surface with noticeable creases due to its folding onto a roll. So it isn't perfectly flat. For the testing shown here, a 6 by 6 square foot area enclosed by wooden boards is used. And here's the plastic area, the white plastic I just showed an example of. To simulate desert soil and dust, a red clay soil sieved to below 177 microns is used. Here's some of the soil. As you can see, this is a fairly dusty material that includes some very fine particles as well as some of the larger ones. So it's probably a good example of what you might expect to find in desert environments. The vacuum cleaner used is the battery-powered Roomba, a commercially available product of the iRobot Corporation, developed for home use in cleaning carpets and floors. Perhaps you've seen it advertised on television or in shopping malls. Let me stress that the Roomba was not designed for this particular application and is used here for illustrative purposes only. As the video will show, a different type or modified vacuum cleaner, or GeoVac, will have to be designed for field use in this particular application. The Roomba follows a pre-programmed pattern in vacuuming a surface. It begins with a sort of a concentric circles and then switches over to following along the sides of the perimeter of an area that it's cleaning, and then finally it moves in a zigzag fashion, and in doing so it covers the entire area several times during its pre-programmed cycle. In this particular case, this area requires about 10 minutes to be completely clean, that is, for there to be no additional cleaning to occur. Actually 7 minutes, but we're going to let you see it for 10 minutes to demonstrate that. And in the next segment, we're actually going to demonstrate what we've been talking about with the soil and the vacuuming of the plastic surface. In the following experiment, 50 grams of the red soil previously described has been deposited on the back 1/3 of the plastic-covered area, as you can see back there. When the cleaning is complete with the Roomba, I'll be back to talk about the performance and design considerations for a field vacuum cleaner. This should take approximately 7 to 10 minutes, and so if you're watching this video, you can run it at high speed to go through the cleaning process faster.